Let's solve multiple angle trig equations. So what we have been dealing with is whenever we have sine x equals something, and we solve it that way. But now we're going to be looking at something like this. Sine 3x equals something. So there's going to be this coefficient here that we have to do something with. So let's look at our first one. 2 cosine 3t minus 1. So we're going to solve it just like the others. So add 1. Then divide by 2. So cosine 3t equals 1/2. So we are going to look at where cosine on the unit circle is 1/2. So sine is y, cosine's x. So we want to look at where the x value, let's see if I can pull this up real quick. Okay, here we go. So sine is y, cosine's x. Cosine being x, we want it at 1/2. So that's at pi over 3. And where else? Oh, over here, 5 pi over 3. So at those two locations, cosine is 1/2. So I'm going to just draw my unit circle, pi over 3, and at 5 pi over 3. So this, let's go back, sorry. We're going to say that this 3t is going to equal pi over 3, and 3t is going to equal 5 pi over 3. Because before we would just say x equals pi over 3 and be done. Well, now it has a coefficient, so it's 3t equals pi over 3. So we have to account for all coterminal angles because it doesn't say it's limiting it to just one rotation. So remember last time we did this 2 in pi to account for all coterminal angles. Okay, so we'll solve the first one. So we'd need to multiply this by 1/3. So we'll do the same thing here. So this is t equals, I'm going to multiply, so it'd be pi over 9 plus 2 in pi over 3. No, it wouldn't. Yes, it would. Yeah, it would. Because it's times 1 over 3. 3 times 3 is 9. There we go. Okay, the next one. We're going to do the same thing. That's 1/3. I'm going to put it over here. I think it just helps me a little bit better. So t equals 5 pi over 9 plus t in pi over 3. And we're done. So we are just finding what the angles are, and then we have to account for that 3. Okay, let's go to the next one. Solve this one. Okay, so we are looking where sine is square root of 3 over 2. So we got to look at our unit circle. And we're looking for square root of 3 over 2. So remember, sine is y. So where's the y value? Square root of 3 over 2. So it looks like it's at pi over 3 and at 2 pi over 3. So it's right here at pi over 3. And right here. Oh, I don't like that. Doesn't look right. It should be more upward. 2 pi over 3. All right. Let's double check. Yes. So now we say sine. Nope, we don't say sine. We just say that the 2x equals pi over 3 and 2x or t equals 2 pi over 3. Okay, we have to account for all coterminal angles. So we got to do plus the 2 in pi on both of them. All right, so we'll solve each one. So multiply this by 1/2. So it's t equals pi over 6 plus the 2, and the 2 will cancel on that one. So it's just in pi. Okay, let's do the other one. So it would be, the 2's will cancel on that. So it's pi over 3. The 2's will cancel on that, plus in pi. All right, let's go to the next one. So solve this to isolate the tan. Oh, this should have x over 2. Almost forgot. That would be -1. So we want to look at the unit circle where tan, remember tan is y over x, sine is y, cosine's x, tan is y over x. Where is it going to divide to equal -1? It's, let's look at our unit circle. My circle is a little off. It's a little better. All right, so whenever you divide y over x, you get a -1. So that's at 3 pi over 4 and at 7 pi over 4. Yep. So it's over here. 3 pi over 4. Here, 7 pi over 4. These are pi units apart. So there's actually going to be 2 ways that we can write this one because of that. I'm going to start out just by doing what I've been doing. Plus 1 revolution. Multiply by 2. That would simplify by 2. So 3 pi over 2. And then plus 4 in pi. And then times 2. X equals, that's simplified to 2. So 7 pi over 2 plus 4 in pi. Okay, let's just leave it like that. Even though these are across from each other, like diagonally, they are 180 apart from each other. So we could actually do this. Use our first one and just go in pi. So then we could multiply by 2. So x equals, what would that be? 3 pi over 2 plus 2 in pi. So it's either this or this because they are 180 apart from each other. So we'd start that plus the 2 in pi. All right, let's go to the next one. This one's already solved for us because there's nothing else to do. Tan is isolated. So 4x equals, we've got to look where x is, y over x equals 1. And that would be here at the 45. And that's pi over 4. And that would be here at 5 pi over 4. And they are 180 apart, just like the last one. So we're going to say, I'm going to move this down here. I did not give myself enough room. 4x equals pi over 4 plus, so remember how I said on the last one we could have done it this way? Let's just go and do it this way to begin with, where we just have 180 degrees, which is pi, and then see how it goes pi each time. So the last one did that too. This goes pi, and then, well, all the way to here. And then here to here is pi. So this would be in pi. Instead of writing both of these, we're only going to do one, and we're only going to go 180 degrees, which is a semicircle. All right, so times 1/4. So x equals pi over 4 times 4 is 16 plus n pi over 4. And that would be all of our coterminal angles included. All right, look at 5, and you're going to do this one on